Hey there, this is Workbench or Workbench Quagmire. Welcome back to our free code camp Python certification at 100-ish days. Today is day 63, so we are about 63% done with this whole thing. We have a couple more certification projects, which will probably say take 15 days. Quiz reviews 1. Depends on how long these labs and stuff are, but we're getting very close to the end here. And then we have to take our exam to complete this. So we're getting very close here. So let's just jump right in this theory section, short video hopefully, and we will move on to, let's go back. What was it again? We will go back to build a discount calculator. So what is abstraction? How does it help keep complex systems organized? Now that we've looked at encapsulation, inheritance, and polymorphism, let's discuss the next key concept of object-oriented programming, abstraction. Abstraction is the process of hiding complex implementation details and showing only the features of an object or a system. Think of it as a focus on what something does rather than how it does it. Abstraction is not limited to Python. It's a programming concept that can be implemented in many languages that support object-oriented programming. To illustrate abstraction, imagine you're driving a car. When you're in the driver's seat, you interact with the essential parts like the steering wheel, shifter, the accelerator, and brake pedal. You do not need to know the intricate details of how engines work or how an engine works, how the transmission shifts gears, or the physics behind the braking system. All of those are complex implementation details. That's an abstraction at work. It provides you with simplified interfaces to interact with a complex system. In the case of a car, again, the simplified interface is the steering wheel, brakes, and accelerator, while the complex system is the car itself. As for how Python implements abstraction, it does so through the ABC module. This module provides the ABC class, standing for Abstract Base Class, and the Abstract Method Decorator. ABC is the class that is meant to be inherited from, but you cannot create direct objects from it. It is what defines a common interface of methods and properties that its subclasses must implement. On the other hand, an abstract method is a method declared in an abstract base class using the abstract method decorator. It may have no implementation or a basic default one. However, any subclass must override it to be considered a concrete or instantiable, even if a default implementation is provided. Here's the basic syntax of an abstract class in Python. So we have to import this ABC module or the ABC class and abstract method. And we define our abstract class with our abstract method. It just has pass in it. Our concrete subclass that implements the abstract method. So we have the concrete class 1, inherits the abstract class. Then we define the abstract method. Print implementation is a concrete class, another subclass. Concrete class 2, abstract method, implementation, and concrete class 2. So you have to define these methods. Here's a basic example. So we do our imports. We have an animal class that inherits from ABC. Abstract method makes sound with just a pass. So now we have to create our concrete classes. We have a dog, make sound, self, wolf, cat, meows, and monkey, ooh, ah. And then we can create instances of each concrete class and create a list of instances here. Notice you don't have to name them. You just basically put them in there and it just instantiates an instance in a list. And then we can loop through animal and animals list and say animal.makeSound, and it will output the different make sounds for the different classes that we used. In this example, we're importing the ABC class and abstract method from the ABC module. When we create an animal class that inherits from ABC and creates an abstract method, make sound, in it that each subclass of animal must override. We create concrete classes, dog, cat, and monkey, which must override make sound abstract method. We instantiate the concrete classes and call their make sound method to show how each of them implements the make sound abstract method in its own way. Remember, you cannot create an instance of an animal class. Here's what happens if you try to do that. So if we say we want to make a dog equals animal, it'll give us a type error saying we can't instantiate abstract class animal without an implementation for abstract method make sound. The same rule applies to subclasses that don't provide an implementation for the abstract method. Even if you define a subclass of animal, you can't instantiate it until it overrides make sound. Here's an example. So if we create a bird class and we don't put any make sound method in there, then we go to create a bird, it'll tell us we can't instantiate an abstract class bird without an implementation of the abstract method make sound. Here's an example, another example, this time with an instance attribute you can pass to the instance of a concrete method. So this time we have a name. So, and we have the talking toy. So robot toy inherits from talking toy. We have to create the speak because it's an abstract method, but we don't have to do anything with the name. Teddy bear, same. Dinosaur toy. And then we can create Rusty, give the robot a name, give the teddy bear a name, give Rex a name, and then we could say toys, Rusty, Fluffy, Rex. So these are instances, a list of instances for toy and toys. And then we could say toy.speak, and it'll speak in each different way, just like before, except this time we had one class attribute that was inherited by the subclasses. In this example, we have an abstract class, base class, talking toy, that defines a blueprint for any toy that can speak. The subclasses, robot toy, teddy bear toy, and dinosaur toy, implement the speak method in their own way. When we create an instance of each of these subclasses and call the speak method, each toy speaks in its own unique way. In conclusion, abstraction in Python simplifies complex systems by increasing reusability. You've seen how you can reuse a single method from an abstract class across multiple subclasses while forcing each subclass to provide its own specific behavior. This approach keeps your code organized, flexible, and easier to maintain, especially as your application grows. So let's take our quiz. What is the primary goal of abstraction and object-oriented programming? To expose all internal implementation details to the user? Nope, that's the opposite. To merge multiple classes into one? Nope, that's not true. To prevent methods from being overridden in the child classes? That's the exact opposite. To hide complex logic and only show essential features? Choice 4. How does Python implement abstraction through its ABC module? By allowing direct instantiation of abstract classes? No. By using decorators and inheritance to define abstract methods that subclasses must implement? True. By automatically hiding all methods with double underscore? We didn't talk about that at all. By converting classes to functions? Nope. Choice 2. In the car analogy for abstraction, what represents the simplified interface and the complex system? So the interface is the engine pistons and the complex system is the steering wheel. Nope, that's the opposite. The interface is the steering wheel, brakes, accelerator, and the complex system is the engine, transmission, and braking physics. I think it's choice 2. The interface is the car manual and the complex system is the dashboard controls. Nope. And the interface is the fuel type and the complex system is the tires, spelled very Britishly. Choice number 2. All right, passed our quiz. So next time we will start with this discount calculator. This may get broken up into 2 things too, because these things tend to take a little bit of time. So thanks for watching the video. Don't forget to comment, like, and subscribe, and I'll see you next time.